If you flip to the back side of your note sheet, I'm going to run you through how to use your graphing calculator to graph parametric equations. So I'll try to go slow enough, but you also have the directions written out on your note sheet. So grab those calculators, pause me when you need to. The first thing you have to do is change your calculator to parametric mode. So your mode button, and if you look on the screen, the red button is the button that I'm pressing. So I'm going to go to mode, it's right next to your second. And what you'll want to do is go down, down, down. Do you see where it says function? If you go over to par, par stands for parametric, and you'll just press enter to get parametric highlighted. Now you can second quit and your calculator will just stay in parametric mode. And the biggest difference, really probably the only difference you'll see, is that when you go to y equals, it doesn't look like it used to. It doesn't just have y1, y2, it has an x and a y equation for each of the lines. So let's enter that example that we just saw the video on. So for our first x, x1, let's enter 10 plus 5t. 10 plus 5. And now you don't have to use the alphabet t. If you just hit your X button like you normally would, it shows up as a t, like magic. Have you ever noticed that on your X button it has X, T, theta, N? It has all of those because those are the common variables for our different modes. If you hit enter, let's get our y equation entered. It's 50 minus 5t squared. And hit enter, and that should be good. We've got a set of parametric equations entered. If you were to hit your graph button right now, chances are you're going to see not much of anything good. And that's because of the window. The window really is important when we're talking parametric equations. I'm in radian mode, so a lot of times these parametric equations, the t stands for theta, and so my t-min and t-max are going from 0 to 2 pi, all fancy. What we want to do is we actually want to think, and I'm going to force you to do this. You have to think. So we're talking about that car driving off the cliff. So if you had to guess how long a car would take to drive off a cliff and hit the ground, I don't know how many seconds you would guess, but you actually calculated that. When you were solving for t and your y equals 0, you got the square root of 10. And so the square root of 10 is like 3.16. So basically what I'm saying is that we want time to start at 0, and then our maximum time, we really only need to go up to the square root of 10. Now I could type in square root of 10, but I'm going to go 3.2. And that's just because I found it graphs better when I type in that instead of the square root of 10. I'm going to type 0.1 for my t-step, and what that means is it's not just going to plot a point for that car every second, it's going to plot a point every 1/10 of a second, and that'll just make my curve show up really smoothly. So far we've talked about the time. Let's talk about the horizontal axis. So we can start it at 0. And do you remember how far out that car went? I figure 30 feet should be far enough for the horizontal distance. So I'm going from 0 to 30 on the x-axis. X scale is just how often you want a little tick mark, so maybe I'll put every 5 feet I'll have a tick mark show up. So that'll do it for our x values. Y values, that's height. So let's just think about height. Minimum height. I do actually like to keep it below ground. I like to leave it at negative something or other. Let's leave it at -10 because then, I don't know, then you can see the ground show up. I just like to go a little lower than I need to. For your Y max, remember that cliff was up at 50 feet. And again, you can go a little higher than that. Maybe we'll go up to 60 feet. So we're going to see the height from a little below the ground, 10 feet below, up to 60 feet. And our Y scale is just how often do you want a tick mark on your Y-axis. I'll I'll label it in tens, 10, 20, 30, 40. So now that we have our window set up to something that makes some sense for this problem, hit your graph button again. And we actually have the path of the car. You can see that it's starting out at 10 feet, or sorry, 20 feet, right? I think I labeled, oh no, I labeled my x-axis in 5, so it's 5, 10, 15, 20, 25, 30 on my x-axis. So yeah, it was starting out at 10 feet, I remember. And there it is. It goes just slightly, if you look over here, it goes slightly below the ground, and that's because I rounded that square to 10, so it crashes down, makes a little divot in there. But since I started at time equals 0, and I went to time equals square root of 10, and a little bit more, we can see the entire path of that car. I want you to try out something else now. I want you to find your trace button. It's right next to graph up there. And if you push your trace button, as you push your arrows right or left, you'll see on the bottom of the screen, you're getting all 3 of your values showing up. You get your time, you get your horizontal distance, and you get your Y position, your height. So if I were to ask you certain questions about, let's say I want to know something about when the height was 40.2 feet, there's everything you want to know about it. It happens at 1.4 seconds. It happens when your horizontal distance is 17. We can actually arrow down and see about that ground level point too. Because that's the kind of questions I'm going to be asking you. So if I were asking you, where does it hit the ground? Well, I don't want to be at negative 1.2 like we're seeing right here. So if I go to the left a little bit, and you know, I also don't really want to be up 1.9 feet. So on your calculator, can you get it to say exactly 0 for the Y value? Mine won't let me. I don't think yours will either. And that's because it'll only let us change by 0.1 on those t values. But I have a hack. Here's what we're going to do. If you just start typing in numbers, like let's say I type in the number 2, or even 2.3, it's going to take that as a t value. And so if I enter, after I just straight up type numbers on my calculator, and it knows what I want. So I typed in 2.3, it tells me the great exact position at 2.3 seconds. So when I was down over here and I was having trouble getting Y to be exactly 0, let's pay attention to the t. Remember, it was happening somewhere between 3.1 and 3.2. So then you can just type in your own 3 point whatever. Maybe you want to type 3.15. Do we get exactly 0? Pretty close. 3.16. Even closer. Maybe. So check it out. What if I actually just, let's cut to the chase and type square root of 10. I know that's going to work, so push, just start typing square root of 10. Enter. Bam! There's that 0 we wanted, right? And we know it happens at this time, that's square root of 10, and we even know the position. We know the exact x value, where it comes at. So I think that's pretty sweet that you can type in your own values for t and get really any point that you're looking for. Good luck, work hard, and I'll see you later.